Hello, in this video I'll present the method by which you can calculate the volume of a solid which is generated when you rotate an area around the x-axis, which will create the solid. In this particular example, our curve, is given by the formula the quadratic y is equal to 5x squared plus 3x minus 1. You can see this curve up here. And if you take that between the upper limit of plus 2 and plus 1, you end up with this area here, the area under the curve. And if you take that area and rotate it or revolve it through 360 degrees around the x-axis, you will generate a solid. The volume of this solid is given by this integral here. In this video, we will run through the solution of this problem, but also we will look at the general formulation and derivation of the equation which is used. On this slide, we have an area shown in yellow. And this area is defined by 4 lines. The curve given by the function y is equal to f of x. The vertical line, which is known as the ordinate, at x is equal to small a. The other ordinate at small b, x is equal to small b, and the x-axis. So these 4 lines define this area which you see in yellow. If you take this area and revolve it around the x-axis through 360 degrees, you will end up with this solid shape which you see on the right-hand side. If we want to generate a formula to work out the volume of the newly generated solid, we must first of all consider a small section of the solid. If we look at the function here, we pick our function as y is equal to f of x, and if we pick any point along that function between the lower limit a and the upper limit b, we see here that the height of the function at this point is given by y. If we pick a very thin section at this point of thickness delta x, and then take that and revolve it around the x-axis, we generate this disk that you see over here. The area of this disk is given, normally the radius of this disk is equal to the value of the function at that point, and this disk has a thickness of delta x. The volume of the thin disk is delta V, is equal to the area of the disk multiplied by the thickness of the disk. Since y is equal to the radius of the area, as you can see here, the area is pi y squared, which is the same as pi r squared, and the thickness is delta x. So here we have the volume of a thin disk, one small element of the solid. To develop an equation to work out the volume of the total generated solid, we need to take a series of strips between lower limit x equal to small a up as far as x is equal to small b, and we need to rotate those around the x-axis. In this illustration, we see a series of thin disks increasing in size from left to right, as you can see here. To work out the volume of all of those disks, the total volume is calculated by integrating all of these infinitesimally small thin disks between the lower limit and the upper limit. We do this by integrating all the small volumes, where the formula for each small volume is given as pi times y squared delta x, and we're integrating those from the upper limit b down to the lower limit a. Of course, as delta x in the integral, delta x will go to 0, and in effect, as delta x goes to 0, these disks will become thinner and thinner, and the volume will transform into the smooth volume that you see here. So the correct integral that we use is v for the volume is equal to integral from b back to a times pi y squared dx. In our example, we have the function y is equal to 5x squared plus 3x minus 1, We have to rotate that or revolve that function between the upper limit 2 and the lower limit 1 around 360 degrees. You can see the area between the upper limit and the lower limit is shown in red in this illustration here. We look at our general formula, and then we plug in our formula values for y into this formula. This is the equation to work out the volume of the solid that is generated when we rotate this area around the x-axis. A convenient way to square out this quadratic equation is to use a table. In the table, we lay out the different terms in the quadratic across the top, and we also lay them down in rows. Then in the first row, we multiply all the terms of the quadratic by the first term of the quadratic, the 5x squared, and we get these set of values here. 5x squared times 5x squared is 25x to the power of 4, and so on. Similarly, along on the second row, we multiply all these terms by the second term, 3x. We get these three values. And in the last row, we multiply all of these by minus 1, and we get this series of values. You can see here that the x to the power of 4 is a single one here, so we get that down here, 25x to the 4. We have 2x cubed x to the power of 3's along this diagonal. So these add up to 30x cubed. We have 3 terms with x squared in them. So we have minus 5 plus 9 is plus 4, minus 5 is minus 1, so we get minus x squared. On this diagonal, we have the coefficients of x, so we have minus 6x. And finally here, we have our constant 1, which gives us the constant. So this gives us the formula which we can integrate directly. In this last slide, we run through the integration of this quartic equation. It's called a quartic because the highest power is x to the power of 4. The integral of x to the 4 is x to the 5 divided by 5. The integral of x cubed is x to the 4 divided by 4. The integral of x squared is x cubed over 3. The integral of x is x squared over 2. And the integral of 1 is x. These are tidied up, so 25 divided by 5 gives us 5. 30 over 4 reduces to 15 over 2. And minus 6 over 2 reduces to minus 3. In the next step, the upper and lower limits will be substituted in for x. In this case, the upper limit is put in, it's shown red, and then you subtract, the lower limit is put in, and it's subtracted. These are evaluated. So 2 to the 5 is 32 multiplied by 5, given 160, and so on. If you look over here, you have a third here, 8 over 3, and here you have 15 over 2 and 1 over 3. So to work out these, we'll work with the lowest common multiple over here, which is 2 times 3, which is 6. So I basically will evaluate everything over 1/6. So if I evaluate these terms over 1/6, I get 1016/04 divided by 6. And on this side, I get 61 over 6. And this gives me the volume is equal to pi of 1543 divided by 6. And this evaluates to 257.16 times pi. You can multiply it out by pi if you want to get the absolute value. That's it. Thank you for listening.